Okay, this video will be the polynomials review for Algebra 2. Okay, little reminders on these graphs. All right, the big reminder is this: is that in the end, if you have the polynomials, will be one of these four pictures. Okay, and you could look at this picture to help you figure this out. These are going to be your odd exponents. These are going to be your even exponents, and we're talking about the biggest degree, okay? This is going to be your positive, and this is going to be your negative. So in this case, since mine goes this way, okay, that's like this, so that's going to be a negative. Okay, remember, degree is turns plus 1. So I got 2 turns, that's 2, so I got that for turn points. That means my degree is 3. All right, now remember, if my degree is 3, the zeros have to add up to get to that. Now, I only have 1 0, real 0. So that means there's 2 imaginary, because these 2 have to add up to get you that. Once again, this is negative. It's got 1 turn, 2 degrees, so I have 2. It doesn't have any real zeros. That means the remaining 2 have to be imaginary. This one has this direction that's going to be positive. It has 2 turns. That means it's a degree 3. Okay, I got 1, 2, 3 real zeros. That means I have 0 imaginary. Okay, 0 imaginary. All right, scrolling up. Once again, these both are down. That's going to be negative. Okay, I got 1, 2, 3 turns. 3 turn points, degree 4. Okay, I got 4 degrees. It crosses 1, 2, 3, 4 spots. That means that's got to be 0. Okay, this one, both are going up, so that's going to be positive. I got 1, 2, 3 turns. I have degree 4. It crosses once and twice. Okay, so oops. So that's 2 there. That means that this has to be 2 as well. Okay, this one is a positive. It's got 1 turn, 2 degrees. Okay, that is actually a double. Okay, number of real zeros. You can circle 2 for that. Okay, because it's a double root, that means this has got to be 0. Okay? All right. Use your calculator, okay, to get that. Let me pull up the calculator. Okay. All right, so what I want to do is I want to go in and graph this. So I'm going to menu, I'm going to graph. All right, I'm typing in my function, okay, which is x cubed, okay, minus 5x squared, plus 3x, plus 12. Okay, I'm drawing it, okay. All right, F3, exit, draw. That fixes it, okay. Now, if I want to find the maximum, I can just move that up a little bit. G solve max. My max is 0.3 comma 12.4. Okay. Find the minimum. I'm G solve min. 3 comma 3. Okay. So basically what I have here is something like this. 3 up. It looks something like this. Okay. Remember, this is considered negative infinity. This is considered positive. Okay. I only care about the x coordinates if I'm doing this. So I'm starting from the far left, so I'm going to work my way up to 0.3. So from negative infinity to 0.3, I'm increasing. Then because all I care about are these, then from 0.3 to 3, I'm actually decreasing. Okay, I'm going there, and then this is an increase. So from 3 to infinity, I am increasing. Okay, going to the next page. Number 8, okay, state the zeros of multiplicity. Okay, that's going to be 0 multiplicity 2. Okay, that's going to be x equals 4 multiplicity 3. And that's going to be x equals negative 5, and there is no multiplicity on that. State the polynomial that has a 0 at negative 1 and a multiplicity of 3. So I'm at negative 1 right here. If a multiplicity of 2 is at 3, that means I'm going to do something like this. It's going to hit. It's going to do that and bounce right back up. Okay. What is the factored form? Okay, that would be x plus 1, x minus 3 squared, because it has a multiplicity of 2. okay, to write the equation of the polynomial, okay, what I'm going to do first is I'm going to multiply x minus 3 and x minus 3. That's x squared minus 3x plus 9, okay? So what I'm going to do is when I combine that, that's x squared minus 6x plus 9. And I'm going to use the other one, x plus 1. So I got x cubed, x squared, negative 6x squared, negative 6x, 9x, and 9, okay? So that's going to be, my function is going to be x cubed. That's going to be negative 5x squared. That's going to be positive 3x plus 9, okay? And that is considered the standard form, okay? All right, moving on to these. My key points for a cube are 1, 8, I'm sorry, not 1, 8, 1, 1, 2, 8, negative 1, negative 1, negative 2, negative 8. My anchor point's at negative 2, 0, because opposite inside the parentheses, so from there I'm going, markers, I'm going 1 right, 1 up, I'm going 2 right, 1, 2, 3, 4, 5, 6, 7, 8. This other one I'm going left 1, down 1, left 2, down 1, 2, 3, 4, 5, 6, 7, 8. So my graph looks like this, okay? For the one with the fourth root, my points are 1, 1, 2, 16, negative 1, 1, negative 2, 16. If you need help with that, type those into the calculator. Be careful with the negative 1. That's going to produce a positive result. Now my anchor point here is 0, negative 3. So from here I'm right 1, up 1. Okay? Actually, hold on one second. I forgot about the 1/2. What do I do with the 1/2? I multiply those. That's going to give me 1/2, 8, 1/2, 8. I multiply that by 1/2. So I'm 1 right, a half up, 2 right, 1, 2, 3, 4, 5, 6, 7, 8. Same thing. Left 1, up a half, left 2, up 8. And there's my big U. Okay?
Mr. Feldman, please call 6500. Mr. Feldman, 6500. Thank
Okay,
you.
same concept here as before. Use this concept to help you, okay? So, when I look at this, I'm looking at the biggest exponent. So that's exponent of 3, so that is an odd. So these are odds and evens, positives and negatives, okay? So this is an odd, and then I look at, well, what's the number in front? That's negative, so I'm choosing this one. So remember, my left arrow is always negative infinity. My right arrow is always a positive. So at negative infinity, that arrow is going up. At positive infinity, that arrow is going down. Moving over to this one, that is considered an even. So I'm going to pick one of these two. Okay? Now, since that's a positive, I'm picking this one. So both of those are going up. Okay? As I move down to this one, okay? This is x to the 5th. That is an odd. Okay? Since that number is positive, I'm choosing this one. As x approaches negative infinity, that is going down. And the other one is going up. This, I got x to the 4th. That means I'm going to have this one. Okay? So what that means is even. All right? And then I got negatives. Okay? So that's going to be both going down. Okay? So that's that one. All right? Let's go on to the next page. Okay? Put in standard form and state the degree. Okay? So all you got to do is rearrange these terms. So the biggest... actually, if we combine like terms there, I'd have 9, because these two combine.
Ms. De Jesus, you're needed in a meeting in room 1113. Ms. De Jesus, you're needed in a meeting in room 1113. Thank you.
Okay, that's degree 5. Okay, division of polynomials, I'm going to start with this. I'm going to put 2x cubed. 2x times what would give me 2x cubed? That's x squared, which leads to this. Now, what I have to get to is I have to get to negative 7. Now, the only way I get there is negative 6x squared. 2x times negative 3x would give me that, and this would lead to 3x. Now, what I have to get to is I have to get to 11, okay, x. So that's going to be 8x. 2x times what would give me that? Would be 4. This times this would be negative 4. Now, as you can see, I need to get to 5. Well, how would I get to 5? I would have to add 9. Okay, so my answer here is x squared minus 3x plus 4 plus 9 divided by 2x minus 1. Whatever you divide it by, if you have a remainder, has to be there. Okay? Moving down to the next one, same concept. Y at negative 3, that's 3y cubed. That's got to be 3y squared. Whoops. 3y squared. That times that would give me this. That leads me to negative 9y squared. Now, I need to get to 2, which means I'd have to add 11y squared. So that's going to be 11y, which gives me negative 33y. The only way I can get to negative 32y is to add 1y, and that's going to be adding 1, which gives me negative 3. Notice this and this are the same. Whoops, I'm sorry. It's not the same. I get negative 3. I got to get to 2. So how do I get to 2? I would have to add 5 to get to 2. So what I got here, okay, what I have there on that one is going to be 3y squared plus 11y plus 1, all right, plus 5 over, and in my case it would be y minus 3. Okay, that's because that's my remainder. Okay, factoring, you can do this the same way if you wanted to. Okay, now where you go is in the calculator, you go over to equal. Okay, and I'm going to go to polynomial. I have a degree 3. I'm at 64, 0, 0, negative 1. Okay, and if I solve that, I get one of those is 1/4. Okay, one of those is 1/4. So, if it was 1/4, that's going to mean 4x minus 1. All right, my computer's going a little crazy. Okay, so that's going to be 4x minus 1. Let me wait for a second while the computer refreshes. You can also take the cube root of these. Okay, that will also help you. Okay, so what I'm going to have here is one of the factors is 4x minus 1y. Okay, now 4x minus 1y. Once again, you could take the cube root of each of those. That gives you the same thing. I do the same thing here. 64x cubed, so I would need 16x squared, which gives me negative 16x squared y. Now, I do not have that term in my set, so that means I have to add 16x squared y, because that needs to go away. That would be 4x y to get that. So I got negative 4xy squared when I multiply. All right, as you notice, I do not have that term, so I need a 4xy squared. The only way I get that is by a 1y squared, which could give me negative 1y cubed. So, what are my factors? 4x minus y, 16x squared plus 4xy plus 1y squared. Okay? All right? The same thing if you wanted to do this one. Okay? All right? You would find out that your solution would be x equals negative 3, which means one of my factors is going to be x plus 3. Okay? Now, so x and 3, I'm going to start the same process. That's going to be there. I'd have x squared. That gives me 3x squared. As you notice, no x squared terms. So that's going to be negative 3x squared, which the only way to multiply that is negative 3x. Okay? That's going to turn into negative 9x. Okay, that's got to go away as well, so that's positive 9. That's 9, that's 27. Okay? So what my factors are there are x plus 3, x squared minus 3x plus 9. Okay?
Dr. Scott, please call 6500. Dr. Scott, 6500.
So on that one, you could have also used the calculator there, and I could have been 1, 0, 0, 27. As you see, that was x, that's negative 3 for a solution, which means my factor is going to be x plus 3. Okay, so that's one way to do it. Okay, 19, I've got x to the 4th. Okay, now, the concept there is I got to find the set that multiplies the 6 that adds to that, which would be these two. So that's negative 2x squared, negative 3x squared. So those add to get to negative 5, multiply to get me 6. All right, GCF there is x squared. That's negative 2. That's going to be x squared. That's going to be negative 3. So what I got is x squared minus 3. Okay, x squared minus 2. Now, they have minuses, which means I could go further. That's a perfect square root, but square root of 3 is a decimal. Okay? All right, so I stopped. The same thing with 2. Okay? On this one, I'm multiplying, I'm getting 36. The only set there would be negative 1 and negative 36 that would get me there. Okay, let me make that box a little bigger. Okay, let me make that box a little bit bigger. Okay, so what I'm going to have is 9x to the 4th minus 1x squared minus 36x squared, and I got 4. All right, GCF out of this is x is 9x squared. All right, now that's got to be x squared here, which leads to this being negative 1. You could have done a GCF there as well. That's got to be negative 4. Okay, which so that would all give me positive 4 there. So what I got here is I got 9x squared minus 1 3x squared minus 4. Now, since they have a minus, that's good. I can take the square roots of those, so that's 3x plus 1, 3x minus 1. I can take the square root of both of those, so that's x plus 2, x minus 2. Okay? So those are the ones with the fourth that you have to work with. Is x minus 2 a factor of this? Okay, well one thing I want to do is I want to make sure my calculator is set to do the imaginary. So let me do shift. Alright, actually let me go back to menu. Let me go to run. Let me do shift setup. Let me make sure my, I'm going to go down here to complex mode. I'm going to make sure the a plus bi. I did that by hitting F2. Okay, now when I go into menu and go back to equal. Alright, the only way this is a factor is if 2 is a solution. If 2 is not a solution, that's no good. Okay, so I got degree 3. Okay, I'm going to have 2, 8, negative 3, negative 1, and I'm going to hit solve. Okay, now, as you can see, let me make sure I type that in right. Yep, as you can see, I don't have 2 for a solution. Okay, so this answer is no. That answer is no. Alright, moving on. Find all the factors and zeros, given that x plus 1 is a factor. Okay, well what I should do is go in and check. All right, let's go in here. 1, negative 1, negative 5, negative 3. Solve. And as you can see, what this means is, all right, I've got to find all the factors, all the solutions. So I got x equals negative 1 twice, because that's what the double means, and x equals 3. So those are going to be x plus 5, x plus 1, x minus 3. These are the solutions, these are the factors. Another word for that is zeros. Okay? Alright? You're done. Because if I have a degree of 3 and I found all 3, you're finished. Okay? Find all the factors and zeros of this. Okay? So what I'm going to do is I'm going to go back. I'm going to do 2, 1, negative 22, and 24. Solving that, I get those. 2, 3 halves, and negative 4. This one? Alright. Positive 3 halves. Okay? Alright, now, these are the solutions of the zeros. The factors would be x minus 2, 2x minus 3, x plus 4. Those are my factors. I found all 3. Okay? Moving on to this next one, and a lot of this is the same stuff, I know. 1, 3, negative 25, 21. Alright, those are my solutions. X equals 3, x equals, what was that? X equals 1, x equals negative 7. So my factors are here. Oh, and those are factors. Solutions, factors. That's going to be x minus 1, x minus 3. Okay, moving on. Okay. All right, I think there's a couple more here that are pretty much the same, but that's okay. All right, going back to this one, that's going to be 1, 3, negative 16, and negative 48. If I solve that, I get that. X equals negative 4, x equals 4, x equals negative 3, x equals negative 4. Solutions, factors. All we're doing is changing signs. Okay? Now let's go to 26, and this is where we're going to have last 2 are going to be a little bit different, just 2 more, then we're finished. All right? If I go back and do this again, that's 1, negative 3, positive 16, positive 48. It's not the problem that I wanted. Actually, I'm sorry, this should be a negative 16 here. That should be a negative 16. Let's see if that fixed the problem. I don't think. Let's go back and do that. That's not what I wanted there. Let's see if that ends up. Negative 16, I think it's minus exit. That's what I wanted. I'm sorry. Let me go back. I'm confusing you now. All right, that was supposed to be plus this minus that. Okay, so when you have that for your answer there, all right, I get this. So what does that mean? My solutions are x equals 3, x equals 4i, x equals negative 4i. Now, my factors for that, that's going to be one of my factors. Now, I have to use division to get the other ones. So what I'm going to do is I'm going to start with x minus 3 is my factor, and I'm going to do division here. So that's going to be x squared, which leads out to negative 3x squared. Now, I'm already at negative 3x squared, so that's going to be 0x squared, which the only way that would work if that was 0x, which that would be 0x as well. Okay? Now, I need the answer to be positive 16x. So I'm going to put 16, I need 16 there, which gives me 16, which gives me negative 48. Okay? So 0 and 16 had to give me 16. So my factor is going to be x squared plus 16. Okay? I don't have to write the 0x. Alright? Hopefully I didn't make the same mistake on this one. Alright? So I got 2, negative 3, negative 32, negative 30. Okay, so now, here are my zeros. My zeros are 5.1, negative 1.1, and also, I've got a nice one of x equals negative 5 halves. Now, for a factor, that's going to be 2x plus 5. These, since they were non-fraction decimals, I've got to do division to figure that out. So what I'm going to do is I'm going to take that 2x and 5, same process, 2x cubed. The only way that could be is that that's x squared, which leads out to be 5x squared. Now, I need to get that to negative 3, so I would have to subtract 8x squared for that, which would make that negative 4x, which makes that negative 20x. Now, I need to get to negative 32, so I'd have to subtract another negative 12, which is negative 6, which gives me negative 30, which that means I've done it right. So my other factor there is x squared minus 4x minus 6. Okay? Key things you got to be able to do is polynomial division. Have some number sets. Understand this. This times this gives you this. This times this gives you this. If you get the diagonals, they've got to give you what that term is. So if it's 5x squared and negative 8x squared, it's got to give you that. Okay, that's a key part of it. Use the equal and the solutions and, to help you find your solutions quickly. For any of the ones that don't turn out nice and you have to find the factors, you're going to have to do division. Division of polynomials is key.